Hey everybody. So this week three sort of pre-lecture video, which we will then touch on in class as well, is all about working with spreadsheets. Before you fall asleep or like hit close window as quickly as you can. It's not really about spreadsheets so much as you'll see, spreadsheets are sort of like the sort of the core way we tend to interact with data, at least until you get to like very large or relational databases. So essentially, all we're talking about is how do I go from like a CSV file or maybe a tab separated file or a TXT file and actually like open that up in R and start doing things with it. So the first screen I shared here, I want to share the screen for where our actual lecture tab lives. And so in this case, we're under the tutorials tab. We're going to skip over this spreadsheets tab, which is sort of just like best practices for working with spreadsheets, and go right to the starting with spreadsheets tab. And so you can follow along here. The core goal, hopefully, after watching this, after attending class and doing the exercise for this week, is you should be able to, on your own, read in a CSV file into R using the packages and the code we're going to teach you, and perform basic manipulations like filtering rows or selecting particular variables from it. So now what I'm going to do is I'm going to alter the screen share, and I'm going to share my R Davis class repo. And now hopefully you are actually looking at an R Studio window. And then what I'm going to do is rather than having pasted all of the information in ahead of time, typically for these videos, I will try and retype the code that's in the tutorial. It forces me to slow down a little bit. Sometimes it also kind of helps highlight like particular things we're doing or why. So first thing we're going to do, and you can again follow along the tutorial, is we're going to read in the surveys object. We're going to call this object surveys. And so I'm going to type read.csv. And if I start the tab complete, it's actually going to provide an easy way to find the CSV file in the subdirectory without me having to type it. So the data subdirectory came up, I hit tab. Now I'm going to hit tab again. It shows three options. In this case, we want portal underscore data underscore joined. Don't worry so much about why it's called that. Just read the thing in. So hopefully if you ran the same code, it works. You can double check that it works if you look in your environment uh, window in your RStudio. And in this case, mine shows an object called surveys. It says there are 34,786 observations of 13 variables. I can also call something like str, which is short for structure, str, open parentheses, surveys, close, and sure enough, I see this overview of the surveys object. R tells me this is a data frame object, tells me about the rows and columns, and then shows me a little bit about the content of each of those columns. You can also always just type the object and hit enter. In this case, surveys. For me on a Mac, it's Command Enter, and RStudio prints out this object in the console. Since there are 34,000, it truncates it. I believe my R has a limit. In this case, it only produced 76 rows and emitted 34,710. But you can at least sort of print that and scroll around a bit and check out the data frame. We already learned it was a data frame class when we called the structure command. You can also call class directly. So in this case, if I type CLASS, open parentheses, surveys, close, and hit enter, R tells me, okay, this is a data frame object. More importantly, there's a few different functions to learn that allow you to get some detail about your data frame without having to print the whole thing, right? Because that works pretty well if you have like a very small data set, but in general, you don't want to have to view all your data to know things like how many columns or how many rows there are. So there's a few different sets of functions. The simplest one is nrow and ncall. Nrow is short for nrow, ncall is short for n number of columns. So nrow surveys and ncall surveys. And this replicates the information. Oh, I mistyped surveys. This replicates the information that you saw when we called structure, so str surveys, also printed out. the number of observations and the number of variables. But the thing I want to note here is surveys returns a bunch of information and it's sort of a bunch of characters. It's good for like visual inspection, but you can imagine circumstances in which you want the number of rows or the number of columns to actually factor into the code, right? So like let's say you wanted to sample from your spreadsheet and you said, I want to sample rows from the first row to the last row. The last row is the same as n row. And so you might actually want to access the number 34,786 and not just view the number in your console. And so nrow and ncol provide a quick way to do that. You might also want an overview without having to print the whole data frame in your console. So two different functions for that. The head function shows the top, HEAD, and put surveys object within that. And the tail function shows the bottom. So it prints out 6 rows for head, and it prints out 7 rows for tail. If we take a look at, or we read the help function for the head object, and you scroll down, the head function, I should say, you see that there's this hidden setting. So head, open parentheses, x comma n equals 6l. 6l is just R's way of saying the number 6 as an integer. There are complicated reasons why that L is there. Don't worry about it for now. It's just the 6. And so what the default is print the first 6 rows of your object. But we could type something like head surveys, comma, n equals 11. And now R will print out the first 11 rows of an object. So this is actually a secret way to filter, right? Let's say you just wanted the top 3 rows. Head 3 just gives you the top 3 rows. I already showed you the str command that actually comes next in the tutorial, so we'll just skip over that. One other thing you can call is summary, summary, and we're going to put the surveys object in that. And summary on a data frame provides a descriptive variable summary for every single column it finds. Some of those are useful. So year, it tells us like the first year and the last year. Some are less useful for record ID. It tells us the minimum record ID is 1. It tells us the maximum record ID is 35,548. That's not really like a type of summary we want. And then sometimes if it finds a character value, so like calling summary on sex, well, sex is either M or F. And so when R tries to numerically summarize that, it just says, well, this is a character, I'm not going to. So it tells you what class it is. Summary is, there's certain functions in R that appear universal, but do different things on different types of objects. And so if you look in your help file for summary, it says summary is a generic function used to produce result summaries of various objects, basically. And so what that means is there's technically things like summary data frame. Oh, that didn't work. There we go. Summary.data.frame. But you don't have to type that because what happens is when you call summary and feed in a data frame object, there's settings within sort of this overarching summary family that says, hey, if the object that was fed into generic summary is a data frame, call this subfunction summary.dataframe. So R has lots of very helpful sort of coding families like that. So you don't have to call like different hyper-specific names for functions for different types of objects. It'll like filter and find the right one for you for most sort of generic use cases. Okay, taking a pause, transitioning. Now we've overviewed the data frame. We have looked at the top, looked at the bottom, talked about how to sort of view the contents. Now let's pivot to actually extracting things. So let's say you want to pull a particular piece out of your data object. So briefly in class last week, you learned about the brackets. So if we have an object like surveys, surveys, bracket open bracket close. Once you put brackets after an object, that tells we're going to start yanking bits and pieces out of this object. For a vector, you only put one dimension in the brackets. For a data frame, which has both rows and columns, you can put 2 dimensions. So what that means is if I want the first object, I want the object in row 1, column 3, I can enter that, and that's 16. If you want proof, we call head surveys 1. And in fact, we see that the third column is the 16th day. We want 1, 5. That's 2. That's plot ID 2 if you call the first row of the surveys, right? So you can see we're pulling individual elements out. You can also pull multiple elements out. You can do that row-wise or column-wise. What that means is if I type surveys, open the bracket. Now, so what I'm going to do is I'm going to type 1, comma, blank. And 1, comma, blank, and then closing the bracket tells R, show me all the columns in the first row. Or I can type comma 1, blank, comma 1, and that tells R, give me all the the values in the first column. It turns out a data frame also will interpret if you just give it one value with no comma, but it's not probably what you're hoping it'll return. If you forget to specify both an X and a Y dimension or leave an X or Y blank, what you end up with is just the first column. Prove that because calling head on surveys bracket 1 should look like the same values as calling head on surveys bracket blank comma 1. And in fact, yeah, we see those same values. They're recorded in a slightly different format for reasons that I'm not going to get into on this video. But the big thing to be in mind here is just be careful when you're indexing, and that's what this process of pulling out individual pieces is. Careful when you're indexing that you're paying attention to the dimensionality of the thing you're indexing. So if it's a vector, which has only one dimension, it's just a set of values, you only need one unit. You only need one dimension of indexes. If it is a data frame, which has both rows and columns, best practice is to make sure to specify the rows or columns or leave that blank placeholder to signify all the rows or all the columns. Indexing is super flexible. So the cool thing about it is you can select multiple values or a handful or kind of do whatever you want. So you could say something like, I want 1, 3, and then all the columns. And what that is going to say is give me the first 3 rows. A colon between 2 integers is a simple way to make a sequence in R of those integers. So 1, 10 produces the numbers 1 through 10. And so if you index with 1, 10, R will, in this case, return the first 10 rows of the survey object. You could also put multiple values on the column side. So what that might look like is surveys, bracket, blank, comma, 1, 3. So this is selecting all the rows of the first 3 columns. And sure enough, we get 3 columns and all the rows. We can also combine those. So you can say, I want the first 3 rows and the first 3 columns. And so now we get this 3 by 3 of the first 3 records and the first 3 columns. These values don't have to be a sequence. You could do anything you wanted. So you could do 1, 4, 10. So rows 1, 4, and 10, and columns 2, 4, and 6. The trick here is you have to concatenate those values. So if you call a sequence value colon value, it will automatically concatenate those. If you just type random numbers, you have to call the concatenate function. But when I do this, I'm going to get this weird 3 by 3 table that is rows 1, 4, and 10, columns 2, 4, and 6. A couple other features. You can use minus signs and get rid of things. So bracket blank comma -1 returns surveys without the first column. -1 comma blank with the brackets returns all the columns minus the first row. We show an example of this in the tutorial, and it's sort of an example that's purposely kind of obscure, just to kind of highlight the functionality here. If we call surveys, open the bracket, minus, and now we're going to concatenate some values. And the values we're going to concatenate are 7 to n row surveys. Now, 7 to n row surveys is a very large sequence that is essentially row 7 to the very last observation in the survey's data frame. In the tutorial, we actually hardwire that number 74786. Those are the same. N row surveys does in fact equal 34786. It just looks a little neater to call n row. So if we do this, so we're going to subtract the concatenation of 7 to the number of rows in the survey's data frame, comma blank. This is actually the equivalent to calling head surveys. The reason being, what we've said in this first call where we subtracted all those values is remove every single row from row 7 to the end, whereas head said only return rows 1 to 6. Either way, we end up with those first 6 rows. With a data frame, we can also index by the name of a column. So instead of the location of the column numerically, we can call the name. So I can call surveys, and now I'm going to open the bracket, and now I'm going to write a string name, genus. And sure enough, what that returns, I'm going to call the head function so we can look at the top of it. Open bracket, quote, genus, quote, close bracket, returns the genus column. So the reason that might be important is you can imagine you're manipulating data and the variables don't necessarily stay in the same spot every time numerically. Whether you filtered columns or you're moving things around. So the ability to call a variable name rather than a variable location is much more flexible. There are a couple of features here, though, that can trip you up. Watch what happens if I type head surveys bracket blank comma and then that same genus string. Oh, type surveys wrong there. Now what this returned is the same values as before, but a different format. We can actually look at what's going on here. If I call class on that second version, it's class character. If I call class on that first version, it's class data frame. And sure enough, what happened here is that first way of accessing that column where all you do is open the bracket, provide the spring, close the bracket, is R essentially subsets the data frame for just that value. Whereas if you index and say, give me all the rows for the genus value, R returns all those values, not the data frame. Final way of doing this is you can also type surveys, and now we're going to do double bracket, and then let's use that genus string again. And this returns all the values just like if you did the blank comma genus version. So again, we get this vector of character strings for those values. Final way to access that, and you maybe saw me do this or you've seen Tara or Elise do this before, is to actually sort of walk through the data frame object. And so the way you walk through an object in R without, there's two ways you can do it. You can index numerically, or you can also use the dollar sign. So in this case, I'm going to type surveys, dollar sign. And actually, immediately before I even asked it to, RStudio saying, hey, you said that you want to select a particular variable from the surveys object. Here's the names of the variables in the surveys object. What do you want? And I can click around in here. So if I want record ID, surveys dollar sign record ID returns the record ID variable. So if you want a particular column from a data frame and you want to select it by name, this is an easy way to do it. Note, though, that in this case, it's not the string. I did not call surveys dollar sign genus, although that actually works in this case. What I did was I didn't put it in characters because it's the name, like the object name of a column. So it's like a nested set of objects. So surveys $ genus returns the genus names. Okay, pause, take a breath. So far, everything we've shown you is, I've shown you, the royal we, everything I've shown you has used base R functions. We're going to spend a lot of time using what's called the tidyverse set of R packages. Essentially, the tidyverse is just a nice set of code that our developers have built that is a really convenient way of interfacing with data in R. It's called the tidyverse because it's a very tidy, simple, parsimonious, intuitive way of dealing with data in R and manipulating it simply. You don't have to use the tidyverse going forward. We're going to teach it. Part of the reason is learning how to use a package is also a skill. If you choose to use it going forward, that's great. If you choose not to use it, won't hurt our feelings either. But we're going to teach you how to manipulate data in the tidyverse. So the first thing you need to do is install the package. So the code for that is install.packages. Kind of confusing. We want to install one package, but we're going to use the install.packages function. And then in quotes, I'm going to type tidyverse, Tidyverse. I'm going to hit enter. And I've actually already installed the tidyverse. And so R is giving me uh, a weird question that says one or more of the packages to be updated are currently loaded. And so what that means is like I've actually already loaded this and I've been using it in our studio, but just for kicks, I'm going to say no, don't restart. Yes, install. It's going to reinstall the tidyverse. Perfect. Everything worked. I did not get an error message. You can scroll up here and everything seems to be a-okay. So now the package is loaded, but it's not ready to use. The way you make a package ready to use is you call the library function, Labray, and type tidyverse in. In this case, now I don't need quotes because it's actually looking for an object, which is the tidyverse package object. And it loads in. It's going to make a couple threatening messages that we don't need to worry about here about conflict. What conflicts mean between packages is when two packages have a function with the same name. In this case, the stats package, which is a base package, has a filter function. dplyr, which is one of the packages embedded within the tidyverse, also has a filter function. So what it's saying is, hey, if you just call filter and don't tell me what package to use, I'm going to use this new one you just loaded. The other message is highlighting that the tidyverse is actually a family of packages. In this case, when I loaded the tidyverse sort of meta package, it loaded 9 different packages in R, including that dplyr package. You don't have to get into that at this point. It's essentially just a family of small packages that all kind of come together to allow for data use and data manipulation. Okay. So we're going to read in that exact same CSV file, but we're going to use the tidyverse function to do it. So following the naming convention in the tutorial, we're going to call it T_surveys. This will be tidyverse surveys. And now I'm going to do read underscore CSV. Read_CSV is a readr function. Readr is one of the packages in the tidyverse. And it's simply the tidyverse's like alternative code for reading in a CSV. It's a little neater, but it really doesn't matter. Both does basically the same thing. Let's add the data/portal data_join.csv. Gives us a little more info when it's read in, but fundamentally we still get that same number of rows, still number of columns. We're doing well. The first value add is when we read_.csv, it reads in something that looks like a data frame, but the tidyverse calls it a tibble. A tibble actually is a data frame, and to prove it to you, if you call class on T_surveys, turns out there's 4 types of classes. That's really confusing. The last one is the real thing. It means it's a data frame, but there's all these special wrappers around it. Wrappers are like sort of accoutrement condiments that go on a underlying function. And in this case, what a Tibble wrapper does is it says, hey, when you try and print a Tibble, instead of just printing all the rows like happens when you print a data frame, I want you to print the subset and provide a little information about what you just printed. So you get this comment, for instance, that says, oh, here's the actual dimensions. Here's this short, like abbreviated presentation of it, and actually cut off some columns even because it just didn't look nicely. So essentially a Tibble has some wrappers that make for pretty printing in your console. The operations all work the same. So surveys, bracket, blank, comma, one, close bracket, and T surveys, bracket, blank, comma, one, close bracket. Oh, sorry, I forgot to add it. I was like, oh, that looks different. There we go. They return the same values, but you do get this slightly different functionality. So in this case, that last column gives you a vector on the surveys, whereas when we're operating on a Tibble, calling for that first column gives you that column again. I wouldn't bother memorizing this, just recognize that you get the same values, but sometimes like a different format or object is produced, and be mindful of that when you get into more complex operations. Okay, so that concludes sort of the first video on how to get started with spreadsheets and read things in, and then we will start to dive into how to actually sort of like make cool new variables and really filter and manipulate things once we sort of mastered this sort of underlying skill set. All right, thank you.